So let's actually create this. So here was my other one, right? I'm going to go ahead and make a copy of this. So we'll call it Caesar2.py. I'll close the old one. I want to keep this stuff the same, so I have a request to the user to define clear text, and then I have another request to the user to define the shift value. And then I convert the clear text to lower, although I don't have to do that anymore because I'm not using this method. So let's go ahead and delete that. I don't need a counter anymore. This is fine. I like the little bit of space. We have the clear text being converted to cipher text, but I don't need that anymore either because I'm not going to store it that way. Instead, I'm going to add to it, if we look at my flowchart again, I'm going to add to that cipher variable after I convert each character. So ciphertext is going to equal just an empty string. And now let's actually do it. So I can delete all this because none of that's relevant anymore. And I'm going to do a for loop. It's going to do this process for each letter in the string. So for each letter, right? So for, I'm just going to use C. C will be short for character. For each character in the clear text, do something, right? So let's make a variable. We're going to call this currents is going to equal ord of C. Okay, so what ord is that's ordinal. It's going to represent that letter with a number. And then we can tell it that currents is going to equal plus equal itself and whatever the shift value is. And then we're going to tell it that current actually equals something else. It's going to equal the char of that. So that converts it back from the ordinal into a letter. And that was actually why I chose to represent this as C instead of as char, because I didn't want it to get the two confused. And then we need to stick this current letter into the cipher text, right? So 1, 2, 3, 4. Cipher text is going to plus equal currents. All right, so we have a few little issues here, though. So I'm assuming that this converts things well. You know what? Let's try it. Let's try it, and we'll see what happens, and then we can discuss issues. So I'll launch terminal, cd desktop, Python 3, Caesar2.py. Hello. Choose your shift. Let's do 3. Press enter. Okay. So it says an integer is required and it got type string. Oh, of course. I put C here, which is pulling to there, and this should be currents. All right, save, and let's try one more time. cd desktop, Python 3, Caesar2.py. Hello, a shift value of 3. Press enter. There we go. So that worked. That did work. Now, there can be some little issues here, right? So this was pretty nice, but let's try it again. cd desktop, Python 3. Let's choose maybe a string with something that covers a little bit more of the alphabet. So let's go with zebra because it's got the first letter of the alphabet, the last letter, well, a couple towards the start and one towards the end, but it's got a little bit more variety. Hello is all sort of at the start. And let's choose a higher shift value. So maybe like 13. 13 is sort of a special shift value because actually if you do 13 twice, it should decode it automatically. Because 13 is halfway through the alphabet, right? So 13 plus 13 is 26. And if you use a value of 26, you'll come right back to where you started. Press enter. Ron. Well, that is an issue because I gave it 5 characters and I got back 3, and there's a weird space in the front. So what's going on? So let's actually watch what happens as it's happening. So instead of just having it do it all in the background without me knowing what's going on, let's actually print all this stuff. So we'll print current both times, and we can also have it print ciphertext here, just so we can kind of see what's happening. So we'll save it, and we'll rerun it. CD desktop, Python 3, zebra. What do we say? We said 13. Press enter. All right, so there we go. So here's the issue. When I walked through sort of the algorithm just on the slides, I was saying that A equals 1, right? And so then Z would equal 26. But if we look at this, Z does not equal 26. Z equals 122. And A actually equals 97. So that's the issue. What it converts them to isn't the same way that we would logically convert them. So if we want the computer to use the same numbering system that we did, we need to make some changes in here. Now, if A is 97 and we want it to equal 1, then we could subtract 96 from here, and then we could add it back over here. So after the shift is done, it fixes it. But a little problem is, what if it goes past Z? That still doesn't fix this, right? Oh, and plus I obviously can't type. What we need to do actually is we need to make sure that this number right here after the shift doesn't go above 26. So we can add in one more line of code, 1, 2, 3, 4, and we can say that current is equal to itself mod 26. And now, if we give it a shot, CD desktop, Python 3, Caesar 2, zebra 13. All right, so 26. It added 13 to it, but that took it over, so it modded it by 26, and that became M. 5 plus 13 becomes 18. The mod didn't really do anything there, so MR. 2 plus 13 is 15, MRO. 18 plus 13 goes past 26, so that mod knocks it back down, so MROE. And then 1 plus 13, so we get this, Rowan, which is zebra, apparently, at 13. That feels about right, because Z is at the edge of the alphabet, and M is kind of in the middle, so I would put it at about the middle. N puts it right about the middle. Then we have these, which E and B are towards the start. This puts them towards the middle. R is towards the end. It's kind of towards the start now. So this looks about right. I think this worked. And that's good because, you know, I want it to work. Now there is still a slight issue with this. What happens if we try capitals? So CD desktop, Python 3, Caesar 2, zebra, or maybe all the letters in capital. So remember that the computer doesn't think of a lowercase a and a capital A as the same character. So if we do this, we'll go 13 again, press enter, and that is not what it is supposed to be, is it? So if you look, the first thing that should stand out to you is we've got negative values in here. So -6 is a capital Z, and -27 is a capital E, and this capital A is a -31. So it's not matching. So there's different ways to do this, but based on what we already have right now, we could use an if-else statement, right? So we're already turning current into an ordinal of the character, right? So it's converting it into a number, and we know that there's a certain range for A to Z, right? So let's go ahead and modify this a little bit. I'm going to go ahead and comment all of this out. So we're not doing any of that. And we're going to say current is equal to ord of C, just like that. And we're going to say print current. What we're doing here is we're going to get a range. We're going to figure out what is lowercase a to lowercase z, and what is capital A to capital Z. So I'm going to save this. I'm going to reopen terminal, go to my desktop, run the program. So A and Z, A and Z. Choose a shift. Yeah, it doesn't matter. Okay, so potentially interesting here. Notice we wrote, well, I wrote 4 characters, but it kicked out a lot more than that. These 32s, those are those spaces. So even spaces have a numerical value when you convert them. We can see the range from lowercase a to lowercase z is 97 to 122. And we can see the range from capital A to capital Z is 65 to 90. So now we actually have 2 issues, the lowercase uppercase thing and spaces. So let's deal with one at a time. First, what we can do is instead of converting all of the C's to an ordinal, we could do just the characters that are part of the alphabet. And the way that we can do that is we can say if C dot is alpha, then do this stuff. And so if this is true, if this check says true, if C is an alpha character, then it will do this. And we could also say else, just print C instead. So let's try this and see if that works. All right, so we're doing that same thing as before. Shift value doesn't matter right now. Press enter. There we go. So it converted them, but only if they were an alpha character. So that's useful. Now to fix this little bit. So because we told it to only convert things that are alpha characters, now we could do something a little different. We could say that if the value is less than 90, then it's going to know, basically, that it's a capital. And if it's more than 90, then it's going to know that it's lowercase. And if it's not an alpha character, it's not going to matter anyways because it won't be triggered by this stuff. So now what we can do is we can say, we can add in a new if current is less than, what, 97, right? Then it's going to do this stuff, right? So delete the comments. 1, 2, 3, 4, 1, 2, 3, 4. So they're inside of that if. You know, I'm just going to copy and paste because it'll be faster. All right. And we don't need to actually print it anymore because we're not printing. We could actually just do else because we know if it's not, then it's going to be uppercase, right? So else. Basically the same thing again, except instead of 96, the value is going to be 64 because our capital A converted to 65. Then, of course, we have to add that 64 back in, and we do all that, and that looks pretty good. Now, if it's not an alpha character, we're telling it to print C, but we don't want that anymore. We want it to instead make cipher text plus equal C, right? So to equal that space, so to add that into that string. We can get rid of all that, and we can print this, and we can see if it works now. So just to make sure that we're clear, what we're doing is for each character in the clear text, we're checking first if it's an alpha character, and then if it is, then we're going to convert it into an ordinal. And then, if it's less than 97, although actually this should be, what, greater than. This should be greater, my mistake. If it's greater than 97, then we're going to subtract 96, add the shift value. In case it goes over, use the mod 26. Add 96 back on, convert it to a letter, and add that to this ciphertext string. If it's an uppercase, so it's below 97, then we'll do the same thing, but with 64 instead, since 65 was a capital A, same stuff. And if it's not an alpha, we're just going to add it at that moment. to the ciphertext. So hopefully that makes sense. Maybe it'd be a good idea just to print it, just to make it easier to see what's going on here. So we'll say print C, and we can tell this to print the ciphertext, just so you can kind of see what it's doing each step of the way. And actually, you know what? I'm going to actually go ahead and move this into here, because otherwise it's going to also print the spaces, which might look a little confusing in there. And then finally, we'll have this part. Print the encrypted message is... We can close that and separate it with a comma, and that should work. Let's give it a shot. So we'll do hello zebra, since we've been doing both and we have a space in there, and I'll go ahead and throw an exclamation point on there for fun. And let's choose 13 again, so that way we know there's going to be plenty of wraparounds. Press enter. There we go. Okay, so it had an H for the hello, and it changed it into a U. It had the E, which it changed into an R and added it to that ciphertext variable. And then an L, which it added on as a Y. Another L, it added on as a Y. The O, it added on. The Z, so we skipped the space as far as the printing goes, but it added the M, and you can see the spaces there. And the E, and the B, and the R, and the A. And then the exclamation point. A great question, though, is why is that a capital T? So we told this to trigger if it's greater than 97. Ah, okay. And it's not greater than 97 because 97 is A. So this should be greater than 96. And we can save it and run it one more time. And this time we should use capitals anyway. That's better. And that T was wrong anyway. It shouldn't have been a T. That's too far into the alphabet. That N looks better. So this looks pretty good.